What's up guys, it's Josh here, and I'm going to teach you all about Bronsted-Lowry bases and Bronsted-Lowry acids. So here, I made a little example here, and I even got the definitions for you. So a Bronsted-Lowry acid is a substance that donates an H plus ion, and then there's the Bronsted-Lowry base is a substance that accepts an H plus ion. So in this example here, you can see there's hydrochloric acid and water. And hydrochloric acid is the acid right here, and H2O is the base. And then in the end, you can see something happen. There's a switch in H+. So there's CO-, which is like left alone without an H. And then here, there's a new molecule that's being made, and it's called hydronium. Hydronium is when it has three hydrogen atoms mixed with just one oxygen, and it's plus. So you're wondering how the hell this happened. So you can see hydrochloric acid is the acid here, and then there's H2O. So here you can see that hydrochloric acid lost its H plus. It's basically donating. It's the Bronsted-Lowry acid, so it's donating the H plus to H2O, which makes it into hydronium. And then here you can see the setup. And guess what? It's actually wrong. So here. So this is all wrong. All of it is wrong. So here, hydrochloric acid would be acid, and then it would combine with CO-. Okay, when it comes to acid-base strengths, weak and strong acids have different properties. So when it comes to strong acids, they dissociate 100% in a solution. And then when it comes to weak acids, they do not fully dissociate 100%. And here we have two examples to show you. So we have the bar graphs here, and then we have an example that I'm about to show you right now. So in the graphs, you can see that for a strong acid, the molecule HA is 100% dissociated, and then it splits into H plus and A minus. And then for weak acids, HA is not fully dissociated, which leaves a little bit of H plus and A minus. And then here, we have two perfectly drawn beakers here, and then we're gonna use hydrochloric acid and hydrochloric fluoride. So here, so this is gonna be a strong acid, this is gonna be a weak acid. So here, you can say that since it's gonna dissociate 100%, we can say that it's gonna be an H plus here, and then a CO minus. So those are the two atoms that make up hydrochloric acid. So let's just say we'll draw like two more. So that's, if the atoms are fully separated, that means that hydrochloric acid is 100% dissociated. And then here, hydrochloric fluoride is the molecule HF. And here, you're gonna have to put them together because they're not fully dissociated. So we're just gonna write down another one.
So the pH scale is from 0 to 14. And 7 is neutral, so 0 to 7 is acid, and 7 to 14 is base. And then the pH equation is negative log brackets H positive. An example is, what is the pH of solution containing an H positive equals 4.5 times 10 to the negative fifth Kelvin moles. And then you plug it in the equation, negative log 4.5 times 10 negative 5, which equals 4.3.
Okay, just to add on to what Sam said, besides knowing that pH is Mr. Cram's favorite 2-letter word, she just taught you how to find the pH using the log formula. It turns out there's 2 other ways to find out the pH of a substance or mixture. The first one is using pH paper. pH paper is it's a very specialized made. So like if you were to drop it like in water, it'll turn green because that's the color of its pH. Drop it in any substance, it will just turn into the color of its pH. If it's unknown to you, just use any pH scale. The second way is by using 3 certain indicators. Well, these 3 certain indicators helped us out a lot because the way that they change color when it's mixed with a base and an acid. So these 3 indicators are phenol red, bromothymol blue, and phenolphthalein. Phenolphthalein is more like a clear solution, and then when it's mixed with the base and the acid, it turns into a hot pink color. Bromothymol blue, it's a yellowish color when it's mixed with an acid, and then it'll turn into like a slight baby blue color. And then when it comes to phenol red, it's also a yellowish substance, but then at the end it'll turn like a barely pinkish color. So yeah, that's basically 2 other ways how to find out the pH of a substance, and you're also using the pH scale. And yeah, if you have like any more questions about pH, make sure to ask Mr. Cram because I learned everything from him, you know. Alright, so now I'm going to teach you all about a neutralization reaction. A neutralization reaction is when you mix an acid and a base and you have to turn it into a salt and H2O. So I drew a little example here. You can see an acid and a base will have to turn to salt and H2O. A good example would be hydrochloric acid combining with sodium hydroxide. And this reaction could also be considered a single replacement because one of the elements is kicking one of the other elements out, so it could take its place. So in this case, sodium is kicking out hydrogen, so it can be with chloride. So in the end, it'll be sodium chloride, and then the H will go with hydroxide and turn into water. And yeah, it's basically the process when an acid mixed with a base gets neutralized so that it can have a pH of 7. Finally, the time has come to teach you all about titrations. Titrations is not, first of all, a titration is not a neutralization reaction, it's an equalization reaction. When you have to find out the molarity of an acid and the volume of an acid, and you have to make sure that it equals to the volume of the base and the molarity of the base. And if you don't know what the formula is, just by me saying it, here it is. So basically it's MA times VA, and it has to equal to the MB, which stands for base, and A for acid, and the volume of the base. So, and then I even have an example here. So let's just say that only the volume and the molarity of the base is given, but you're only given the volume of the acid. So you're gonna have to put it in this format. You have to multiply MA times 125 milliliters, and I have to make sure that it equals to 0.01 molar times 54 milliliters. So then 0.01 times 54, it would be 5.4. And then you divide both sides by 125, and you get an answer of 0.043 molarity. So that's basically it for this video. Thank you for watching, and I certainly did try my best to explain anything to you guys. If I seem confusing at any time in this video, I apologize. But thanks for watching, and see you guys at school.